So welcome to the third lecture in this IoT course. And in this lecture, we'll continue our discussion on IoT system design. In the first half of the lecture, we'll be looking at the design methodology. And in the next half, we'll take up a tutorial where we will see the different steps of this, taking a specific case study of home automation system. So in the last class, we started discussing about how do we build an IoT system. And we initially discussed about that the idea of any IoT system is to build a solution to a problem which will be available any place, anytime, and anything communication. So the idea is that we want to solve a practical problem, a day-to-day, a problem that will help us in our day-to-day lives. And for doing that, we will be making use of any device that is available readily. And we will try to do that. I mean, we will be using these devices in such a way that our solution would be able to help us in any place that we want. Obviously, any place means that any specific place that we would like that particular solution to exist, and anytime. That is whether we want it to be at daytime or night. So depending on all these factors, we plan to come up with a solution that will help us solve a particular problem. Okay? So this was the basic idea. Now, in doing so, we understood that the IoT is basically a connection of two kinds of world. A physical world where we have physical things that interact with the physical environment. We call them objects, things, smart objects, whatever you want to call them. And on the other side, we have the place, the virtual world, where the data collected by this physical thing is worked upon. This is the world where you do different kind of computation. So the data that you collect, you want to make some useful, you want to extract some useful information from the data. And based on that, you want to perform some you want to take some analytical decisions, or you want to control some physical device. So these two can only happen. I mean, this can only happen if you extract some meaningful information from the data. And that is what is done by the virtual world, the information world, whatever you call it. So this is the way things happen. So you have physical things that collect data and passes on to the virtual world where this data is worked upon and some information is extracted out of that. Well, this virtual world consists of a lot of things. It involves certain devices, it involves certain applications, certain software that works on this data and extracts information from them. And these two things, they coexist. So physical thing, for every physical thing, you have an equivalent virtual entity. We'll see that today itself when we'll be looking at a case study of the home automation. So we'll see how for every physical object, there will be a virtual object which will be created. And all operations that you do would be on the virtual object corresponding to the physical object. So this is the idea behind building an IoT-based system. We already have had a basic idea of how IoT works. We have an environment, which is the physical world to which the sensors interact. So these two, they interact. So the sensor interacts and collects data from the physical world and passes it on to something called a device. That's an embedded hardware. So the data that it passes on from here is a raw data. And if the raw data, the next idea is to extract information from the data. If the embedded hardware is capable enough to do that, that is fine. So the local computation is good enough to extract information from the data. If not, then it takes help of more sophisticated infrastructure and takes help of internet to pass on to something called, let's say, this heavy infrastructure called cloud. So there the data is transferred, and all analytics, decision making, etc., that runs on the cloud. So all in all, this cloud, it actually provides some kind of service to the lower layers, which are the embedded hardware, the device that is actually collecting data. So the low level device, we often call it the edge devices. So they require some services from the cloud. What kind of services? Data storage, some computation to be done, etc. So the edge devices transfer the data, store it on the cloud, and then for progressing the computation, they talk to the cloud to provide different kind of services. Okay, it's like this. So the cloud is not only an infrastructure, but also a service provider, different kind of services, file storage, file management, okay, communication between the low end device and the high end device. So it's kind of some web-based services. So all this is responsibility of the cloud. This is one end of the pyramid. The other end is the users here, the people who would be requiring or who will be making use of this entire system. So the people are also involved in this IoT ecosystem, and they are the ones who are the end users. They want to see the data that you have collected. They want to see the meaningful information that you have extracted from the data. And they also want some services. So the question is, whom would they request the services? Again, it is the cloud. So the final end user, the people, they also would be requiring the cloud to give them the services, also through some services. And that can be some applications that are running on the cloud, which the users would be executing to look at the different, to get those different services. The data that we have stored, the file, the database that we have stored here, they want to get that data. That will also, the users will also be allowed to do that. So this is the overall picture of how IoT works. And at the same time, you may also require some control that you would like to execute on a particular device. So this is called the actuation. That's also an end device. That's also a device which is a physical device. So again, the data that you would like to send to the physical device so that it can be controlled also can come from the cloud, depending on command sent by the users or command sent by some other physical device. So a command comes from the cloud to the end device, and then that controls on some other physical device. So overall, this is the picture that we have about IoT, and this is what we want. Okay. We saw that this is the simplified model. Overall, we have something called nodes. We call them the edge points, the nodes, whatever, and they consist of sensors and devices. Now, these two, the sensors and devices, may not be sufficient to handle the data, or there may be multiple such nodes. So the decision making, the analytics, control may not be possible with the node. So you need to take help of other sophisticated infrastructure. And the first step is to collect the data from all such nodes. And that is the reason why we use something called gateway. And this gateway has a lot of role to play. It's a very, very important thing that sits in between the cloud infrastructure, that is actually the service provider, and the physical device or the end device. Sits in between the two is a gateway that does a lot of things. The first is, as I've told you, aggregation of data from a lot of nodes. Then there is a very interesting connection that has to be there from a low network communication to an existing infrastructure on IP-based communication. As you see, the nodes that get connected or the nodes that are being used, they make use of very simple protocols because they are very low-end devices. These are very low-end devices. They use very simple protocols like Bluetooth, Wi-Fi, These are communication protocols which are very simple, that is low power, low range communication protocols. They are only required for communication to a small range or to a very low power device. So if you want like to use these nodes for connecting to the internet, it may not directly be possible because they don't have those capability. So they use only very simple kind of protocols for near communication. But on the other hand, we have to use internet because we have to make use of applications and cloud. So what is to be done? And that means there is some kind of a connection that has to be done between a non-IP based and an IP based. So here we have some kind of a non-IP based, communication that goes on between the nodes and the gateway. And on the other side, you have an actual IP based communication, which makes use of the TCP/IP stack for communication between one device to the other. And this is where the gateway plays a very, very important role. This is the basic idea of a gateway, that you collect data from a non-IP based device or communication, and you actually transfer it to an IP based, make use of an IP based communication to send the data. So this is the one of the main reasons of using a gateway. We'll talk about that later on. We already seen the IoT ecosystem, so there's nothing. We've also tried to relate that to the existing TCP/IP stack or the OSI model. And overall, if you there is no as such any specific IoT any such kind of a network stack. This is all that has been designed or thought of based on the different applications or the different ways in which IoT systems are built. So there are pretty some common architectures which are there. So we've already seen that. I'll just recap that overall the IoT architecture consists of 4 layers. Okay, the lower layer, which we call the device layer, that consists of the devices and the gateway, the actual devices that interact with the physical system and collect data. Then comes the network layer, where we are interested in the different communication that would be taking place. The low range communication, the low power communication between the devices and the gateway. On the other side, between the IP based communication between the gateway and the cloud, or directly between the device and the cloud, that can also happen. So what kind of networking capabilities should we take into account? How will the data will be transported from one device to the other? That is the thing to be considered in the network layer. In the service layer, we talk about the different kind of services that has to be provided. Now there is a service provider and there is a service requester. There are some services which are very common, like I would like to access from the device some application, some software. So some very basic web kind of services will be required. Okay, some services that will be running on the device, like operating system, etc. So they're very generic services, and some will be very specific because different IoT systems will be built for different purposes. So obviously you have to have some specific requirement. So accordingly, the service requirement will be different. Okay, we'll talk about that in today's case study. And finally, we have to develop different applications. So overall, there are these 4 layers: device, network, service, and applications. These 4 layers are the ones which are at least required for building any IoT system. Apart from that, you can also add some management and some security related stuff to enhance your IoT system. But these 4 are at least required. You require devices, you require network for communication, you require some services because these devices will be communicating, and you require an application for users to make use of that IoT system. So at least these 4 layers. This is another way of looking at, and we have already seen. So let me quickly come to the different IoT levels which we discussed in the last day, because today we are going to move towards the design of one such IoT system. And it's important that we recap this IoT level because it's the different designs that we are going to look at or we'll try to design will be one of those. So if you have a clear understanding of the different IoT levels, a lot of specification or idea about the design becomes clear there itself. So here we have, when you think about an IoT system, you first of all try to divide that into different components and try to see which component will be executed where and how many components are required. Based on that, you come up with different levels of design. So the common, so if I can split this up, the entire IoT system into different components, the ones that will come into my mind are first and foremost the device. So this is the physical thing that actually I will be requiring. What is the device that I'm going to use for my system? What will it be used for? Number one, it will be used for identification, because you will connect that particular device to the internet. Okay, and internet has millions and millions of devices. So every device should be identified. There is a particular way to identify. We already have one existing identification technique for our network of computers. And that is, we associate a particular number to every computer. We call that the IP address. So that's a unique identification number through which you are able to identify a particular computer. Pretty similar to that, there must be some kind of an addressing for every device that you connect. Because when one device would be communicating to another device, which is the motive of IoT, the devices will connect. How do I know which device to talk to? So there must be some address associated with every device. There must be some kind of an identification. Okay. So an IoT device, it should allow identification. Next is it should allow remote sensing. So you should be able to remotely capture the data. So data should be able to be captured. You should be able to actuate and remotely monitor the capabilities. This is what you expect in a device. I've already discussed about the different, we will be talking about different devices in the next lecture. So the first thing is you need to have a device. Based on your system, you will be deciding what kind of a device should I choose. The next is resources. Okay. Resources are the software components which will be allowing accessing, processing, storage, everything related to which will be helping me in working with the device is what you call resources. So they include the hardware, they include the software, primarily the software, which will be interacting with the IoT device to do all that which the device is expected to do. Like you want to access something, you want to process something, right? You want to store information, or you have to control the actuators. All this will be done by the resources. Then we have the controller device. And as we have already, controller service, as we told that there is a service layer and there is someone who's going to provide the service. So for that, you need some kind of a mechanism that will be, or some kind of, service provider. So we split that service into two halves. One is called the controller service. That will be the native service, okay, that runs on the device. And this service will actually be interacting with the web services. So how will your users or your devices connect to the cloud? There will be some kind of a web app, right? Some kind of a web service that you provide. We'll talk about in details about the different kind of web services. We'll be designing them. So in order to request that web service, there must be some lower level services which will be running at the device level, some operating system level, very basic or fundamental services, which will make use of the web services. So web services are sitting on top of the lower level services. Okay. So for example, you want to use a web app. Well, for that, you need to use some kind of a message passing technique. So there, the message passing technique should be supported by your lower level services. Okay, only then can you make use of some kind of a web app which will be making use of the message passing services. So say for example, the controller service, it sends data from the device to the web service and receives commands from the application for controlling the device. So the command that comes from the cloud to your device will be the top level command. Okay, so that has to be interpreted and reduced to a form that will actually be understood by the device, because the device understands a particular way of the device can only work if it is given a command which it understands. So it's the responsibility of the controller service to convert that into the device level command. Okay, only then the device will work. Then we have the database where you actually store the data. Okay, either it is a local or you have stored it in a cloud. And finally, we have the web services. There's a link between the IoT device and the application and the database. So everything is the connection is through the web services. We will specifically be talking about this kind of web service because it has its own advantages, and we can also use the existing web services such as HTTP or a WebSocket, whatever. So we have already seen that. And then comes the thing that actually works on the cloud. It's either an application that will be an interface which the users will be using to view or monitor or control, or it will be some kind of an analysis that you're going to do. Some AI related algorithm that you will be running on the cloud that will be doing some data analytics and giving you some results based on that, which you will be using for either your visualization or for control. So here is the analysis component where the machine learning algorithms, the AI algorithms, they will be in use at the cloud. Okay. We saw this. Let me quickly go through and then we'll take up one such IoT level. So if you look at those 5 to 6 services or the different components of IoT system that we discussed, and now we try to find out, just keep this in mind. It's a 4-layered architecture which consists of device. On top of that, we have network. Then we have the services, and top of that, application. So that's a 4-layered. Now, if you try to go a bit deeper and try to expand everything, you have devices, and on top of that, you have resources, right? Resources are hardware and software resources, such as the different software components. Then on top of that, the different kind of services. Services can again be divided into 2 categories: the controller service, the application of web services, and then we have the application, and we have the analytics. Well, application analytics for the time being, we'll assume that they are one and the same, and they will be the final level that will be used by the users. Okay, so overall, the picture is like this. Here we have, as you see, we have device, resource, controller service, the web services, and the app. So these are the 5 things that we are interested with. Okay. Now, if this, and obviously we have a database as well. So let's go to 6. So this, how are you going to use these 6, components of your IoT system, and where are you going to put them? That will dictate the IoT level of your design. Now, if things are very, very simple, that you don't have a lot of computation to be done, the data that you will be generating is a very limited capacity, you don't need sophisticated infrastructure like cloud. You don't need that. Everything, all this, whether it is a device, simple device that collects some data from the physical world, a very simple operating system that is running on the device, and it is just a very near communication. You just have to take some decisions which are very, very local. You collect the data, like turning on and off on particular electrical appliance, depending on the amount of light or some data that you have captured. It's a very local control. There is no far off communication that is involved here. No IP based communication required. You just get the data, do some kind of a very basic computation, like whether it is crossing a threshold or not. And if it is there, then you decide whether you turn on a switch or turn off a switch, or turn on a bulb, turn off a bulb. It's a very, very simple design. Okay. The data generated is also very small. So your device is sufficient to handle that data. So the database is also a very limited capacity. So you see the device, the controller service and the database, they are very, of limited capacity. Okay. So data is not big. The analysis is not computationally intensive. So there is no need for a cloud. So one single node is good enough that will perform both sensing and actuation, and will also host the application. So you will get the application right there at your node itself. You can run an application there and control that. A typical example is home automation system, where you have in the mobile phone, which makes use of, let's say, the infrared sensor to control the different application. A very, very simple idea, right? So you just install a controlling device along with that particular appliance. There's a sensor, as the actuator itself is the electrical appliance. The sensor will collect the data, pass it on to the mobile, and the mobile is making use of the infrared technology to communicate to that particular device, whether it is a sensor or the actuator. It's a very local communication, maybe Bluetooth or Wi-Fi. That's also very near communication, and you don't need a very lot of computation to be done. So that's the level 1 design. Level 2 design is you move one step ahead. Now the data that you capture is big, but your computational requirement is still not so much. So you have data is big, but the analysis and computational is, doable. So what you do is to be, because your data is big, so you have to move the database out from the local node. Okay, you cannot handle so much of data. And because the database has moved from your node, there is a simple device, to a third-party infrastructure. It can be a server, it can be a cloud. So if your database has moved to a different computer, automatically you need to now talk to that other computer. So you have a device, which is a processor, which will be running the very basic resources and the very common controller service like OS level controller service, etc. But that has to talk to the other computer which will be hosting the database. And that will be, for that, you need some kind of a services, some kind of web service. So either you make use of REST service or WebSocket services, and the controller service will actually be requiring this data. Okay. So either the controller service will be making use of the data via the web services, or it will be again making use of any web service to make or to access the app. The application will also be running on the cloud. So this is IoT level 2. From here onwards, you start taking help of third-party infrastructure. Okay. Typical example is smart irrigation, where you have many sensors. Each sensor that you deploy for doing some purpose will be of a specific type, of a specific, because requiring some for a particular requirement. So you have, let's say, you want to monitor the health of your plants, okay, or you would like to. So the smart irrigation means you would like to plant your seeds depending on the current weather. You would like to know the amount, the soil content, whether what kind of seeds should be planted. You would like to know the amount of moisture in your soil, whether you would really be needing some water, and that too, the water will be depending on the amount of soil moisture. So keeping this in mind, you will try to find out what kind of sensors I will require. I'll require temperature, moisture, pressure, okay? And each sensor will be collecting some data. It will have a local data collection or aggregation center. So it will have a device associated. But because there are so many sensors and so many devices, that the data will be heterogeneous. The data will be of different kinds. okay, so of different variety. So you have to require some kind of a third-party infrastructure. So you have to use cloud, and there the database will be maintained automatically. This means it's an IoT level 2 design. Application will also be cloud-based. There will be only one application that will aggregate everything and show you, and that will also be running on the cloud. Okay. IoT level 3 and 2 is pretty same, except that the computation now becomes more intensive, and the analysis, maybe you do some very extensive analysis on the data. So that is one of the reasons why you have more of a cloud usage in case of IoT level 3. And as you see here also, the web services, the database, the app are all on the cloud, but the computation is a bit more intensive than in IoT level 2. What kind of a computation? Maybe real-time computation. And in case of the temperature and monitor, you don't do computation. You are more interested in, let's say, storage of data. The sensors, they collect the data, and the storage is more. Computation is like just comparing a threshold. But in case of IoT level 3, the computation will be more intensive. Say, for example, you have to compute something in real time. At every minute or every second, you have to compute something. That will be difficult. Typical example is tracking package delivery. Now, where you are trying to find out whether the package is in its position or whether it has rotated or moved or fallen down, what is happening in that particular package. So you have attached some sensors to that package, and that sensor is collecting data, which is the position, the lateral position, the angular position, the motion, the tilt. So we see two sensors I've written here, gyroscope and accelerometer, that measure the motion and the tilt. And that data is constantly being fed to the monitoring device. And what you are doing is, this data that you are computing is giving you the position. And as the vehicle is moving, that data is changing every minute, or rather every second. And in real time, that data has to be computed and it is giving you. So it's not only the data storage, also the data computation that is being done in real time. That is the problem with IoT level 3. In IoT level 4, we move from single node to multiple nodes. So situations where we have multiple nodes, let's say this is node 1, this is node 2, and each node will be trying to communicate to the cloud, or will make use of the web services to communicate to the cloud. So here you see that this is node number 1, this is node number 2. So node number 1 communicates via the web services or the REST services to the app or to the database. Similarly, this also communicates to the app or to the database. Okay, so each is independently making use of this. There are some, so data is stored in the cloud. Okay, application is also cloud-based. And interestingly, here we have some kind of an observer node. This is a very interesting thing. There are some local analysis that has to be done, some local analysis, but this observer node, what it does is, this is the node which actually collects from data from the cloud. It puts the data to the cloud, or it collects the data from the cloud. Okay, so it receives the information from the cloud. So this is basically the the way in which you communicate to the cloud. You have the nodes that are putting the data, right? And we have two kinds of nodes. One node that is local, which is at the device level. That is the node through which you collect the data or you get the information. And then we have another node which is in the cloud, okay, the observer node. So they are the ones that visualize the data from the cloud. Example is the noise monitoring system and where the sensors used are sound sensors. Okay. As you see, we deploy different places these sensors. They collect the data. There are multiple sensors, so multiple sound sensors will be there, but so each will be collecting the data from different positions. Okay, so you want to find out what is the total amount of noise that is going on in the city. So you deploy these noise sensors at different places, near railway tracks, near parks, bus stands, okay, stadium, etc., marketplaces, and each one of them will be collecting the data, real-time data. For let's say 24 hours, you collect periodically. Let's say at every minute or every hour, you collect the data, and there are maybe hundred of nodes, such nodes in throughout the city. They collect the data, and then you aggregate that. Number one, or you can see in real time which node is collecting which kind of data. So there is an observer node that will be communicating to the cloud and will be obtaining that information from the cloud. So every node is putting the data to the cloud, and that observer node is making is able to visualize that, okay, by collecting the data from that. We'll talk about some subscribe thing later on. Then we have the IoT level 5, which is again multiple nodes, but it's an extension of IoT level 4, that here we have some kind of coordinator node. So as you see, this is the coordinator node. So we have a coordinator device. Look, the difference is previously each one of them were independently making use of the REST services. But here, this node N1 is actually communicating to the coordinator device. You see here, this is N2, node 2. This is also communicating to the coordinator device. And the coordinator is actually making use of the REST services to get the app or the database. This is the difference of IoT level 5. You have a coordinator that will actually, so this is in this way. So the endpoints will actually be talking to the coordinator, and the coordinator is the one that is responsible for communication to the cloud. We have observer nodes here as well. And this is the place where you have, this is application is typically where the data is big, the analysis is computationally intensive, and this is more suitable in case of wireless sensor networks. Okay, we'll talk about wireless sensor networks later on. So just to give you a very brief, we know that sensors are the devices that are required for connecting or for obtaining some physical devices, right? Now, along with that, if you make the sensor to be smart, that is, you have some processing capabilities you put in along with the sensor. Okay, so it's a smart sensor, we can say, that you are able to not only collect the data, but you want to do some processing, and that's part of the sensor. So that's a smart sensor. Now, what do you do with the smart sensor? Well, you put them or you deploy them in a certain area, and you connect them. You create a network of that. So you have sensor and you have a network of the sensor. Okay, why? They want to communicate among themselves. They want to send send data, and if they want to communicate via, let's say, the wireless medium, okay, you call them the wireless sensor. So you have the wireless mechanism of data transfer between these sensor nodes, and together they form a network. So overall, simplistically put, this is what you can say, it's a sensor network. So you have multiple nodes. So you create a network of those nodes which communicate among themselves. They have to be, because if you require the devices here are communicating to a coordinator. So the devices themselves have to communicate. It's not that they will be individually communicating to the cloud. So that is the reason why they need to have a network. And one among them will be a coordinator. Let's say this fellow is a coordinator. Okay. So it's a distributed system where each node is connected with each of all the others, and one among them is given some special facility called a coordinator that will actually be communicating to the cloud. So it works in this way. Typical wireless sensor network deployment. Where do you use that? Forest fire detection. Different places you put the nodes. Each node is collecting some information. and also passing it on to the others. There's one coordinator that is getting the, okay, so the coordinator will be collecting the data from everybody, and then it will be passing on the information to the cloud. So when you get the data from temperature, smoke, weather, slope of earth, speed of fire, you add and you pass it on to the cloud. In the cloud, you actually get that data, and then you decide that, okay, it's indeed a fire or not. That is how you have to decide. So there are a lot of things which are involved when you use these kind of systems. So as I told you, we have a lab that way where we have a wireless sensor network. We can create a basically wireless sensor network of a very within a small region, and we can work on that, how all the sensor networks can work together to build a system. Last, we have the IoT level 6, which is, as you see, pretty similar to 5, except that there's a centralized controller, and the controller is here in the cloud. Okay, this is the centralized controller. So the cloud, so each one of those are actually talking to the, not a coordinator node, but a controller, which is located in the cloud. And this is responsible for communicating to the cloud and making use of the web services, right? So this is basically the difference. A more complex system, and this is the one that makes use of the IoT level 6, the weather monitoring station. Okay, so this is about the different levels. We had already covered that in the last class, but I thought that because this is very, very important, I thought I would be recapitulating these concepts before we move forward. Okay, so let me quickly go through one of the very basic, some of the basic communication models. We will be talking about that later on, but for the time being, let me just introduce you to the concept, because when I will be talking about the system design today, we will be needing these models. So the first, what kind of communication models we will be using? I'm talking about models. I'm not talking about specifically any protocol, just the different kind of models that we are going to we use while building IoT systems. The most common one is called request response model. What is this model used for? We already know about the basic server client architecture. I think all of you are aware of the server client architecture. You have taken a networking course. What is the basic principle behind a server and a client? The basic principle is that we have a resources, we have a process or a system that does not have sufficient amount of resources, and the other computer or machine, it is a very resourceful system. It has a lot of resources. Resources means you have high computing power, high storage, okay, memory, bandwidth. So you have sufficient amount of resources, hardware and software resources that is available to that particular machine to carry out any particular task. That is the meaning. And on the other side, we have a computer that does not have sufficient amount of resources. Now the question is how you can use these two together so that everybody, so that the client which does not have the resources can also make use of it. This is the idea behind client server architecture. So the idea is that this server, we could give the name server because it provides the services, is having the resources, files, memory, okay, computing power. And the client will put a request. As you see, it sends a request. The server, on getting the request, looks up to the resources and sees whether it has the resource. If it has the resource, it sends the response. This is the procedure. This is we typically call the client server model of communication. Well, here also there can be two ways. Now the request that you have and the response can be completely provide the resource. So the resource comes to the client and the client works with that. Say for example, it requests for a file. So the file is entirely provided to the client, and then the client works on the file. This is called an upload download model. or it can be a remote procedure model where the response is like it provides a resource and access to the resource, but the resource will still be in the server. There will be no copy of that in the client. That can be. So it's like remote access of the resource. You get the resource, but you are still accessing it remotely. It's in the server itself. You're not getting a copy of that. It can be that. Okay. So this is one model that we can think of, that one device, one IoT device, if it wants to communicate to either another IoT device or gateway or cloud, we can follow a client server architecture. But this is the most simplest. It did not work in that way. We have to modify this model. The most widely used model, and the one that we'll also look at, we'll study different protocols based on that, is called the publish subscribe model. This is the best model that we will be preferring. Why is this client server not important? Because number one, you have to establish a connection. And you have to always, you don't know when the data will be coming. If you are aware that the data is there, then you can go for a client server. But if you're not aware of that, then it's impractical to always get a client connect to the server. See, for connecting to computers, it's easy because all are mains powered. So but if you have a device that is battery operated and you always connect it to a particular device, then there is a chance that the battery will drain out. So you cannot keep a small device, an IoT device, always connected to some heavy computer. It's not possible. Or you can have, or you have to have some kind of a main supply always plugged in. That's not possible in many cases. So you have to think in alternate ways of communication. And the best mechanism is like this, that there is someone who wants to send me a data, and there is someone who would be using the data. Well, the person who's sending the data and the person who's using the data, they need not know each other. Say, for example, when you watch television and some program is broadcasted, the person who has broadcasted the program doesn't need to know who is watching my data, who is watching my program. His job is only to broadcast, right? And your job is to look at the one that you are interested in. This is called publish and subscribe. So I publish my data and you watch it. So I have created a content, I put it on YouTube. I am not interested to know who is watching my content. And you, who's a subscriber of my channel, will be watching my content whenever I post my data. So that means on the publisher side, I have nothing to do. I simply create a channel and I start publishing videos. As a user, you are the consumer. Your job is to get connected to my channel, and that is called subscription. Now, the reason why you want to subscribe is because you want to get an updated data. Whenever a publisher puts an updated data, you immediately get that. That is why you see the YouTubers, they say that you subscribe to my channel so that whenever I put a new data, you get it. That is the idea behind the publish subscribe model. So we have one kind of a device or person who's going to send the messages, and what he's going to do is he's going to look at the messages and I post videos related to music, in other I post related to education, and third I post related to politics. I do that in that way. So I design or I divide my content into different topics and I publish messages based on those topics. Now, as a consumer, you will be subscribing to one of my channel, my politics channel or my entertainment channel or my education channel. And accordingly, if you subscribe, you will be getting notifications about the new videos that have been posted. Now, who will maintain that? Well, here is the broker. Think about this as a YouTuber, YouTube. That's actually maintaining it for me. Okay. So he's dividing that into different topics. Education. Who are the subscribers? He maintains a list of the different consumers. Here we have consumer 1 and consumer 2 who have subscribed to topic number 1, the education channel. Okay. So any message that will be posted by the publisher will immediately be made available to the consumer 1 and consumer 2 through this particular thing called broker. So for a publish subscribe model, I need a publisher, I need a broker, and I need a consumer. The consumers are the one who are the end users. They will be subscribing to the particular topic, and whenever there will be a notification, they will be getting that. This is the idea behind publish subscribe model. This is the most widely used model in IoT based systems. We are going to look at a protocol called Mqtt, which is based on this particular model. Okay, this is the model that we are going to use. We'll see more about Mqtt later on. The other model is push-pull. It's again, we have a publisher, we have a subscriber, but here we don't have any broker. It does not maintain it in the form of topics, but rather we design some kind of a queue where you push those messages and the consumers will be pulling them from here. Okay, this is an alternate to the publish subscribe, except that there is no broker here. There is no topic wise distinction. You just put it messages in a queue and one by one this is fetched. Okay. So the queues here are acting as buffers. It's a very, this rudimentary message passing concept that we are aware of, where we maintain the queues and the messages are put in the queues and one by one these messages are read. Okay. Third model is the exclusive pair. You actually have a client server that I've already discussed about that. You request for a connection. The connection is set up. Look at this. Client has requested for a setup of connection. Then the response was accepted. Then it starts sending message to the client. The message server comes back. So you go on sending and receiving messages. And finally, the client says, please close the connection, and the connection is closed. Okay, this is how it happens. We are all aware of this, and it's a duplex communication. Communication happens on both sides. The one that will actually be requiring is something called REST. You must have heard of this term, or if you have not, because if you are dealing with IoT, you will be hearing this term. Now the HTTP, right, Hypertext Transfer Protocol, which is the mechanism for data transfer between client and server, the most commonly used protocol for text, images, video. This is the protocol that we usually make use of for transferring of data between one computer to the other. Well, the same thing people thought initially, that can we have HTTP protocol for transfer of data? The problem is that HTTP is very bulky. Okay, so the amount of data that you will actually be transferring if you are making use of HTTP is not possible with low-end IoT devices. So you have to have some kind of a modification to that. Only then these IoT devices can communicate. And then came the concept of REST. It was already there. It had nothing to do with IoT, by the way. It was already there, just that its features were found very suitable for use in IoT. So that is the reason why this REST architecture has become popular for communication among IoT devices. But this was way, it was not designed for this purpose. It was just a kind of an idea that was given. What is it? It says that it's a representational state transfer. So let me put it this way. We'll detail that later on. It's just a basic idea that I'm giving you. It's an architectural principle, okay, of designing web services. We just studied that we need web services. We need web applications for communication between device and cloud, between device and the the application that will be running on the cloud. So will this work? What we do is we design some kind of there are some kind of an architectural principles that are designed that you have to do it in this way. Some constraints are put. Okay. So if you want to design some web services, you cannot use the general web services that you are working with for designing an HTTP based web service. What is that? Now, there are some APIs. APIs, I think all of you know, application program interfaces. You can put simplistically as something like function calls. There are some libraries of functions that are given. Okay. Some methods that you are going to execute. You just have to know that. Now, we call them REST-based APIs. So there are some, objects, some methods or some function calls that follow the architectural requirements of the REST architecture, the REST architecture principles. Okay. What is the basic motive behind these architectural principles? The motive is that ultimately when you are using the web or a web service, you are interested in the resources. That is the basic motive. You want a file, you want a memory, you want some, network. So if getting the resources is important. So the focus is on the system's resources and how the resource states are addressed and transferred. This is the basic idea of API. How do you get the resources? How the resources data will be transferred? This is what the REST API will be interested in. And the REST API is actually based on the request response model because it's based on HTTP. So HTTP is based on request response client server architecture. So it is a request response model. You have to request for some service and you will get the service. It's that way. The REST architectural constraints, they apply to components, connector, data elements within a distributed hypermedia system. More of that we'll talk about later on because we don't have this time. So I'll be presently leaving that. Okay, so with this, I move towards my tutorial and let us now move into the design methodology. So now we have sufficient amount of idea to move ahead with the design of a particular system. Let's take a case study and understand. Before that, I will stop and take any questions if you have. Any questions regarding whatever has been covered so far? Is this clear? The basic definition of IoT, the different components, the different layers, the different levels. Okay. So the only thing that you should keep in mind is the 4 layers, how these 4 layers are distributed among different local and cloud. That is sufficient for the time being. Okay. Well, so let's take up a case study. And the case study we are going to take up is a home automation system. IoT level 1 design. Simple. Let me start off with a simple case and then I'll gradually make things more complex. Okay, so let's begin with, first of all, a IoT home automation system. Idea is, let me focus it further. I will only control the light. Okay, depending on my present light information of my room, I will turn on or turn off the light. Let's think it in this way. Okay, so the first thing for any design, whether it is a hardware or software, you must have also taken a software engineering course. And for design of a software, what we first do is we get the specifications. I hope you remember something called SRS, okay, software requirement specification. So same thing happens here as well. The first thing you need to do is you need to know, this is the step number 1. And we need to know what is the purpose for which we are designing. What is this IoT system designed for? And that will decide what are the requirements for my design. Okay, so this is the first step. You have to be clear about what is the purpose of the particular system, the solution that you are providing, and what are the requirements. What are you going to solve? Home automation system, let's say, or maybe I'll be asking, suppose I'm going to design an IoT based smart umbrella. When I'm going to take that with me, it will be able to give me the information about the weather. Okay, so purpose: protect me from rain, give me the weather information. Requirement: depending on the current weather of the weather, it will be able to either turn on or turn off. That's the requirement. Okay. Okay. Process model specification. This is step number 2. So what is this process model? Process model is, once you have understood that this system is for this purpose, create what are the processes that particular this system will be able to do it. Let me give you an example. Let us go one by one. In the first, we have, because we are dealing with a case study as a home automation, let's talk about that. Purpose is a system that will allow control of lights in a home. Okay, it will be able to control remotely using a web application. So I will be able to control the lights remotely using a web app. That's my purpose. Okay, what is the behavior? The behavior is I will have 2 modes, an auto mode and a manual mode. Manual mode means through my web app, I will be as a user, I will be able to turn on or off the light. Auto mode means the system automatically will be deciding whether to turn on or turn off. Okay, how? So as you see here, auto mode means the system measures the light level and switches the light when dark. And manual mode means system provides the option. It just gives me the information. I have to go or remotely switch on or off. So these are the 2 modes I have, auto mode and manual. Done? Okay. So behavior is system management. What is the management that you are going to provide? I should have a remote monitoring. I will be able to see the information. What is the amount of lightness, or whether the bulb has been turned on or off or not. And control means I will be able to remotely control that. So these are the 2 things I need to do. Data analysis, well, it's a local analysis. You don't have so much of computation to be done. Just comparing with a threshold. Application, where you will be deploying the application. Okay, the application should be deployed locally on the device, but should be accessed remotely. So the application will be deployed locally, but it should be accessible remotely. Look at the requirement. Okay, security. Okay, you have a basic user authentication capability. Only the bona fide user will be able to see that. So purpose and requirement are decided. Let's move to the next one. Process. Well, this process will come from, by the way, the behavior. So here is the one that will decide me the behavior. Let me first look at what do you have in a process. In process model specification step 2, you define the use case. What are the possible use cases? Okay, right. So we have very similar to, this is the process model diagram. We start and we have the operations that will be done. So this is the mode, as you see here. We decided that this will have 2 modes, the auto mode and the manual mode. In auto mode or in manual mode, in both, what you need to do, you need to look at the state of the light. Okay, so if you are in auto mode, the system will automatically work. So you have to look at the light level, and deciding on that, you will decide whether it is low, so you have to turn on the state on. If it is high, sufficient light is already there in the room, you have to turn off the light. Okay, so this is about the auto mode part. Manual mode, you have to give an information. So look at the manual mode, you see the light state and you find out whether the light is already on or off. Okay, so you just have to find out the state. What is the present condition? Because manual mode means you are giving an information to the person that see, it is currently in this state. Do whatever you feel like. You want to keep it on, you can. You want to turn it off, you can. So it's just an information that is provided to the user. This is the process specification. Okay, step number 2. Step number 3. Step number 3 is domain model specification. Well, now, so far it was very, very abstract. We were working on a very abstract level. We are only just deciding on the process. Now you have to translate that into an actual home automation system. This is the domain that you are going to come into. So where you will actually be defining the physical entities, the virtual entities. In the start of the class, I told you that for every physical devices have to be mapped to their corresponding virtual counterpart, because the modeling will be done on the virtual thing. The data will actually be captured by the physical thing. Okay. Then we will be defining the devices, what kind of devices we are using, resources, the services. These 3 have to be decided now because we are moving into the actual domain. Let's see. Okay. Is it visible, the diagram?
It is not visible clearly.
Okay. Just a minute. Let me check it. Yeah. Is it visible now? Or should I increase the font again?
So please increase the font again.
Okay. Now see?
Yes,
Is it
sir,
okay?
now it's okay.
Okay. Now let's look at how things are working. Okay. Let's have a look at here. Just keep in mind what we need to do. We are going to design the system, so the domain has to be now introduced. And for that, we have to decide on the device, resources, services. Okay, these 3 things. Well, so first of all, let me scroll a bit down here. So we start from here. Here we have we will be using this kind of nomenclature, that you have a device that will be represented by square box, and it will be split up into 2 compartments. And the top will write type. Type means whether it is an entity, a service, or a resource. We will do it in this way. Okay. Okay. So if it is a service, if it is a device, let's say we start with here. So what are the sensors you are going to use? What are the devices you are going to use? Think yourself. It's a home automation system. You are controlling the light. So what is the sensor you will be using? Anyone? What is the sensor you will be using? The diagram shows. So you will be using a sensor that will be able to pick up the light information from the room. It's called LDR. LDR is light dependent resistor. Okay. It's a kind of a device whose resistance changes when light falls on that. And if resistance changes, the current changes. Okay. And that is an indication that there's some electrical quantity that has been designed, which is obtained from a variation of the physical quantity, and that is provided to you. So the variation in the light is equivalent to variation in the current, and that is what is provided as the data. So if this is calibrated, let's say some change in the light will equally be reflected as change in the current. So this is the sensor that will pick up the light information. Now, what will be the actuation? Actuation means what are you going to control? Our design is to turn on and off a switch. For that, you will need some motor, some kind of a switch. We call this as a relay. Okay. Ultimately, this relay will be connected to the bulb. So if you turn this off, this will be off. This will turn this on. This will be on. So basically, you are controlling this thing, the relay, which is called the actuator. So sensor here is the LDR, the light dependent resistor. Actuator is the relay that is connected to the light source. Good. Now let's look at the arrow. So the sensor will be providing the data to a mini computer, okay, which is the device in this case. So this will be providing the data to the mini computer. And what are the resources that we have running on the mini computer? You have an on-device resource, which is operating system, let's say, that is hosted on your mini computer. You have a network resource, right, which is the different connections that you will be establishing to send the data. And these two, they make up the resource. So the resource that we are talking about can be network resource, on-device resource. Good enough. Then let's move ahead. Now, for these two, we have, for the LDR and for the actuator, for every physical quantity, which in this case is the appliance and the room, right? Appliance is the one that you actually control, the actuator. And physical entity, the room, is the corresponding light intensity of the room. So these two are the physical entities. This is, you monitor the light of the room and you act on the appliance. That is why I've written monitors and act. Now the physical quantity has a virtual entity called room that you create, shown in green. And the physical entity called appliance has a virtual entity called appliance. So you clearly create two virtual counterparts of both of these. So these are the two that are actually created in the cloud or in the application side, on the software side, on the virtual side. And they are associated with some service. Room will also require some service. Appliance will also require some service. What kind of service? Well, we'll have some web service. What kind of web service? As you see here, it's invoking some or putting some services. What kind of service? Well, the room is getting some information of the light intensity of the room. So the virtual entity room is capturing some data, which is the light intensity. And it is putting that via some mechanism, via making some use of services to the cloud. Okay. And what the user is doing is, the user, as you see here, is making use of this web services and getting the information about the room. That whether the light intensity is below a threshold or above a threshold. So it is interacting with that particular virtual entity. Physical entity room, getting the data, its equivalent virtual entity maintained in the app or in the cloud is getting updated with that particular data. The user is making use of the services to see the data which is stored there. Okay. And similarly, if the user wants to send some control to the appliance, it will also do that via the services to that appliance, and the appliance will be controlled via this. So this is the idea behind the domain model specification. So you have the domain model and you control that. Next, information model specification. Let me go back. What is in information model? Step 4. Here you define the structure, the relation, the attribute. I think all of you have taken a software engineering course. Have you studied design of an UML diagram? How many of you remember study of an UML diagram? Class diagrams? Did you remember? Did you take a software engineering course? Okay, so you forgot. Yeah, so did you go through class diagram design where you build, suppose you want to build a software, how do you do that? You build it from the most top level design, right? You design something called design flow diagram. Have you heard of this term? Entity relation diagram, ER diagram. Have you heard of this?
Yes, sir.
Yeah. So you create entities, you create relation between them. So that helps you in visualizing the software. What are the steps? How what are the layers in that software? How are you going to design that? Same thing here as well. It is a design procedure. So now we have step number 4. We are going to use the entities and we are going to create a relation between them. So the two entities that we are going to talk about are the two virtual entities, obviously, because now we have shifted from here to the virtual world. Physical world has gone to the virtual world. So there are two virtual entities, the room and the appliance. Question is, what is the data that each entity will be storing? So the virtual entity room will be storing an ID, because there can be many rooms, room 1, room 2, and each one of them can have sensor. So it's important that you give an ID to that and you give an entity type, room. Similarly, for the appliance as well, you give the ID, which is light 1, entity type is appliance, and you associate the room 1 with this particular appliance. Okay, so that means that it is in room. So the appliance is in the same room. So this one is the association that you build. Okay. Now we've already decided that there can be two possibilities, auto mode and manual mode. In auto mode, we are interested in the system automatically detecting the level. In manual mode, it will look at the state of the appliance and will tell the user that this appliance is currently in this state. So in the auto mode, when you are looking at the light level, you are calling this as the attribute. So for every entity, okay, you have a corresponding attribute. So the attribute in this case is the light level. The attribute name is light level, attribute type is level. For a state, you have an attribute name which is light state and the attribute type is state. Okay, so attribute level has a light level. Yeah, if it is high, has a light level. So this is the relation that we have, which you check about the attribute and you find whether it is yes or no answer depending on that, whether you have a level high or level low. Similarly, looking at the attribute type, what is this corresponding state? So attribute name light state is in state what, on or off. So this is the entities which have been defined, their attributes and their relation. Okay. Now it's time for us. So we have built the device, not yet. So we have just decided on the process. We've decided on the domain. We've decided on the information. Now we connect what kind of services we are going to provide. Okay. So what we do is, it is just looking at the process specification and the information model, we decide what kind of services we require. And you remember the services were controller service and web service. Let's try to split this up into, for this particular problem. We have one service that will be called mode service that we have to provide, the system will be providing so that you can select the mode. We will be giving some kind of a state service which will be able to set the light appliance to a particular state. And then we have the controller service, which will be able to switch the light on and off depending on in the auto mode. Okay, so primarily we have three services that comes out of this process and information model. Controller service, which will be helping me to control the light in auto mode. State service, in manual mode I will be able to look at the state and decide. And third, I will be able to select which mode I should go, whether I should go to manual mode or auto mode. So this is again the so this is about the service specification. Okay. Once the service specification is done, now I am in a position to decide the level. Okay. So step number 6 is IoT level specification. I think by this time you are able to guess that it is an IoT level 1 design, because everything is happening locally, right? You are collecting the data, that is, you are sensing, etc. Everything you are doing it here. The controller service is also running on the device. You have a very small database to handle. All services are running locally. So obviously it's a level 1 design. Now, once you have designed this, how about mapping that to each one of those 4 layers? So level 1 design will be mapping to the 4 layers. Okay. Are you able to see that? The diagram?
Yes, sir.
Okay. Now it's for you to just map and have a look. So on the left hand side, what you see here is the device 1. Okay, look at the arrows that are connected. So the device, which is 1 and 1, okay, here. So as you see, this is the layer. So IoT device, it maps to the device, which is sensors, actuators, device, computing device. So device in the IoT level will actually map to the device layer here. Okay. And will also be mapping to the management part. That is, it will be also related to device management. Okay. It is just an information that which layer in that IoT level design will actually be mapped to which layer. 2, resources. The resources, they map to the device as well as communication. So some part of the resources will be to the devices, or sorry, to the this 2 here. Okay, this goes right into communication. So some other resources will be related to communication, and some part will be related to the device. Okay, for example, the resources related to hardware. This will be related to, for example, the operating system. It will also handle the working of the device, as well as it will also take care of the network, the web sockets, the message passing, etc. So this is about the resources. Third, the controller. The controller service, as you see here, is about maps to the services, the web services. Okay. So the controller service, as we have already told you, is, see here, it is mapping to the service layer, which will taking care of native services and web services. Okay. Fourth, the web services, they map to the service layer. Fourth, this one, it straight away maps to this service layer. Okay. Fifth, the database, which is this part, it maps to the management and security. Yes, because database, when you need to know how am I going to manage the database. So you have a management to be done of the database, okay, which is this. And you also have to secure that. So it also goes into application as well as security. So it's very important to consider the database and have to keep that secured. The idea that we are trying to convey in this step 7 is which layer comes into which particular services and what should you care about that. Okay. Finally, about 6 is application. So it's nothing much to talk about. It has to be taken care of the so application is like it will handle the web app, the application server, the database. This is the operational view, which will give you the idea about the different operations that will go on. Device, we will now decide on the device, what My computing device is Raspberry Pi. Please have a look at this because we'll be starting off from here. My computing device is Raspberry Pi. My sensor is an LDR sensor. My actuator is a relay switch. So my device complete. Now I'll move up. Communication. What communication am I going to use? I'm going to use REST-based APIs. I have already decided that my sensor and actuator will be LDR and relay. So my communication protocol, which communication protocol I will use? Link layer is 802.11, maybe Wi-Fi, wireless, any wireless communication I will be using. Network layer, I will be using either IPv4 or IPv6. Network layer means connecting the device to the cloud. I will be using an IP-based addressing. Transport, I will prefer TCP model, TCP kind of communication. So there will be connection established and then connection will start. Application, for the timing, let me assume that I will be using an HTTP protocol. If I will be building an app, web app, and if the device has to communicate to the web app, it has to be through HTTP. So there will be HTTP packets going from the web app to the device or from device to the web app. Done. Let's move ahead. On the services side, what are the services I will be giving? Native service will be controller service, nothing much in that. It will be handled by the operating system. Web service, I have to design a mode REST service and a state REST service. If you remember, we just decided there will be three services: controller service, mode service, and state service. If you have to provide those services like controlling the mode, controlling the state, how are you going to do that? Those two services will be making use of REST APIs to provide the users these two modes or these two services. So that is the reason why I will be using two services: mode service and REST service. Sorry, state service, and both will be of REST type. Done. Next comes application. What application I will give? Web app, application server, database server. I will need three servers. For web app, I will be using Django web application. For application server, I will be using Django. And for database, if I want to maintain a database server, I will be using MySQL. Okay. App management. For application management, because there's an application I have to manage web app, application, and database. So I have to manage all the three. For application management, I will be having Django application management, MySQL database management, and device management will be Raspberry Pi device management. Security, I have to provide authentication and authorization of all the three: web app, application, and database. Okay, so now more or less I'm ready. Last, now I have to build. So my hard software level part is okay. My decisions have been taken. I'm ready with the design. Now I will start building the device. This is my Raspberry Pi that I have used. This is a small mini computer. The mini computer has a lot of GPIO pins, which I have. From the GPIO pins, I will be connecting them to wires, and I will be using some sensors here. Details about this part in the next class. So GPIO pins, and I have connected some sensors and an actuator, both the relay and the LDR. This is the application that I will be designing. This is the interface that users will see. They will see two modes, okay, auto and manual. And if you want to turn off, it is manual mode. If you want to turn on, it will be auto mode. Light, you can turn on and off. So this will be giving you the mode. This will be giving you the state. This is the dashboard that you are looking at. Now you are designing the different web services, and the different web services will be designed. We'll talk about that maybe not now, because we will require some more understanding of the web apps, etc. Only then you will be able to design all that. So for the timing, let's assume that this is the step. Once you have designed the interface, now you will be designing the services, and the services will be web services. Finally, you will be integrating everything. So let's look at, okay, device. Raspberry Pi to which sensors will be connected, resource, operating system running on Raspberry Pi, controller service, native service implemented in Python, so that like handling the data, controlling the sensor, turning on the switch of the actuator, database, SQLite, REST services, which will be providing the web services. They will be implemented in the Django REST framework. That will be having all the necessary services to provide you or help you in designing this. And finally, the app will be a Django application. So overall, this is the situation, or this is the design that we have. Okay. So building from scratch, figuring out what is to be done, deciding on the process, the domain, the information, stitching all the three, designing or thinking about the different services to be provided, building the design, and then moving on to the web app and the services. So overall, this is the step-by-step methodology of building any IoT-based system. Specifically, we discussed about the home automation. So the next class will actually be showing you design of this system. But before you do that, we'll take a bottom-up approach. We'll first build the devices. Then we'll be coding that to interact with the sensor and the actuator. Once done, we'll be moving on to put some services on top of that. And then we'll see how the services can be made use of. And finally, we'll build some application. So from the next lab class or tutorial class, we'll be seeing how we can program the device, or what are the resources that we can make use of, such as connecting different sensors and actuators. And for that, we'll be using Raspberry Pi. But to program Raspberry Pi, we need Python. So the next class, maybe tomorrow or day after, we'll be teaching you some very fundamental concepts on Python, and we'll also show you how you can program Raspberry Pi using Python. And specifically, we'll be focusing on implementing different modules and specific networking concepts using Python. So that is all for today.